stayed. I think it's important that everyone here who's spent the time to get here have a chance to be heard today on this important topic. So what I'd like to go ahead and do is introduce our next panelist for his opening statement. Dr. Karl Schoenbach, a professor and eminent scholar from the Frank Reidy Research Center for Bioelectrics at Old Dominion University, located in Norfolk, Virginia. The Frank Reidy Research Center works to develop medical diagnostics, therapeutics, and environmental decontamination. Dr. Schoenbach, thank you for joining us.
Chairman Nayev, thank you for inviting me. I'm representing the Frank Reidy Research Center for Bioelectrics today. It's a interdisciplinary research center, and we have about 40 faculty, graduate students, and technical staff. We focus on the study of biological effects of electrical pulses and try to develop new therapies based on these bioelectric effects. And one of our major applications is the treatment of cancer. We are doing very well in basic research, as shown by the funding, which we get mainly from NIH and the Department of Defense, by a large number of publications and invited talks all over the world. We are less successful in transferring, however, our research to industry. Two examples. Already in 2002, we have shown that we can, with very short electrical pulses, kill cancer cells very effectively. And in 2006, in animal experiments, we could demonstrate that we can eliminate melanoma tumors completely with these short pulses. We have tried since then, since 2006, and actually before that, to find companies who work with us to bring this technology to market. And we were only successful now this year to find a company who is willing to work with us. Another example is based on research developed for the treatment of melanoma. Also, in this case, we have developed an efficient method using electrical pulses to deliver genes directly into the tumors, which then stimulate the immune system and destroy tumor cells. We could show that this therapeutic approach is not only effective in treating tumors locally, but it also prevents new tumor growth, and it eliminates metastatic tumors. So even with these exciting results which we got, we were not able to get support from companies immediately. It took us 2 years to get support from a small business which helped us to get the equipment in place and financial support from a cancer center to do a phase 1 trial. And again, this gave us fantastic results. We are still searching for companies who help us to support a phase 2 trial. Again, because of a limited availability of research dollars, we have not been successful yet. In both cases, we lost valuable time, which could have been used to bring our therapies to cancer patients. The problem is that the university researcher is still focused on basic research. It will only demonstrate feasibility in preclinical studies or early phase clinical studies, and will seldom go towards the full development of therapies. This is considered to be the task of companies. Small companies, on the other hand, would understandably like to minimize risk when taking on new projects and would like to only take on, quote, mature projects which are only in a certain stage such that the risk is relatively small to continue. So there is a gap between university research and development at small companies. And any incentive which helps to bridge this gap, to lower this barrier, is extremely important for university research, and tax incentives could be one of them. I think it would definitely help to get our research at the universities better to the market and faster to the market if it would lower this barrier.